I welcome you all in this session. Today we are going to convert an NFA into DFA that accepts set of all strings over A and B, where second last symbol from right hand side must be A. So for this, first we will find the sigma here, that is A and B. Here we have to accept the string like AA, AB, AAA and AAB and so on. Here you can see every second last symbol is A in every string. Here our language L will be infinite. Now first we will construct an NFA, and with the help of that NFA we will construct the state transition table, and using that state transition table we will convert the NFA into DFA. So first we will construct the NFA. So here you can see we have constructed an NFA that will accept any number of A's and any number of B's before the occurrence of the second last symbol A, and after this second last symbol there may present either A or B, means the last symbol may be either A or B, but the second last symbol is A, so it must be A only, and before the occurrence of second last symbol A there may exist any number of A or any number of B. So here you can see this NFA will only accept the string having second last symbol as A. You can check for any string like AAB. So on input small a from initial state A, our next state will be A. Now on input small a from state A, the next state will be B. Now from state B on input small b, our next state will be C, and we have reached the final state C. So the string AAB will be accepted. Likewise, you can cross check all the other strings. So this will be the NFA that will accept the given language. Now we will construct the state transition table with the help of this state transition diagram. So the column here represents states and the row represents inputs, input small a and input small b. So we will see from the initial state A. So from initial state A, on input small a, our transition will move to state A and also state B. Means from state A, we can move either on state A on input small a, or we can move from state to state A to state B on input small a. So that's why we have written here this set of two states, that is A and B on input small a. Now we will check for the input small b. From starting state A on input small b, the next state will be A itself. So we have written here A. Now we will check for the state B. From state B on input A, the next state will be C. So we have written here C. Now we will check for the input B. So from state B on input small b, the next state will be C. So we have written here C. Now we will check for the state C. So on input small a, we have no transition from state C on input A. So here we have written empty set. Now we will check for the input small b. So from state C on input small b, there is no transition available. So again we have written an empty set here. Here in this state transition table, you can see this arrow. This arrow represents the initial state and this star will represent the final state. So here A is a initial state and C is a final state. Now with the help of this state transition table of NFA, we will construct the state transition table for DFA, and with the help of the state transition table for DFA, we will construct the DFA. So first, we will use this state transition table for NFA to construct the state transition table for DFA. We will start from the initial state A. So starting from initial state A on input small a, we are moving to two different states, that is A and B. So in the case of DFA, we cannot move to two different states on a single input. Means we cannot move to two different states on a single input, that is small a. So we have written here as AB. AB here represents a single state. In DFA, we will consider it as a single state, namely AB. Now we will check for the input small b from state A on input small b, the next state will be A. So we have written here A. Now we will check what are the new state we have found. So here we have found AB, it is new state, and we have already seen the transitions on A here. So now we will see the transitions on state AB. So from state AB on input A. So for this, we will take the union of these two. We will take the union of these two from the state transition table for NFA. So on input small a, we will take the union of these two. So it will give ABC as a result. So we have written here ABC. Here also we will consider ABC as a single state. It will represent a single state. Now we will check for the input small b. So on input small b, we will take the union of these two. So it will give AC as a result. So we have written here AC. We will take this AC as a single state. in DFA. Now we have two new states, that is ABC and AC. So first we will see the transitions on AC. So on input small a, we will take the union of A and C. So we will take the union on input A. So it will give A, B, because from state C on input A, there is an empty state. So it will give AB. So on input small a, it will move to state AB. Now on input small b, we will take the union of these two. So it will give state A. Now we have seen the transitions on AC. So we will now see the transitions on ABC. So we will take the union of ABC on input A from the state transition table of NFA. So we will take the union of these three and it will give ABC on input small a. So we have written here ABC. Now on input small b, we will take the union of these three. So it will give AC. So we have written here AC. So now we have seen all the transitions on every state. Now here in the state transition table of NFA, state A is an initial state. So here also in DFA, state A will be an initial state. Now you can see in this table for NFA, state C is a final state. So in the state transition table for DFA, every state having C will be the final. So in this column you can see this state and this state contains C. So both the state will be final, AC and ABC. Both the state will be final state. Now using this state transition table of DFA, we will construct the DFA. Now we are using this table starting from the initial state A. Starting from the initial state A, on input small a, the next state will be AB. So starting from the initial state A, on input small a, the next state will be AB. Now on input small b, the next state will be A. So starting from the initial state A, on input small b, the next state will be A. Now we will see the transitions on state AB. From state AB on input small a, from state AB on input small a, the next state will be ABC. So the next state will be ABC. Now on input small b, the next state will be AC. So from state AB on input B, the next state will be AC. Now we will see the transitions on AC. So from state AC on input small a, the next state will be AB. So from state AC on input small a, the next state will be AB. Now from state AC on input small b, from state AC on input small b, the next state will be A. Now we will see the transitions on state ABC. So starting from the state ABC on input small a, from state ABC on input small a, the next state will be ABC. So the transition will move to ABC. Now on input small b, from state ABC on input small b, the next state will be AC. The next state will be AC. So this will be the equivalent DFA that will accept the given language. Here you can see when we will start from the initial state A, when we are having input small b, the next state will be A, and there may exist any number of b here. Now whenever we will encounter the symbol small a, we will move to state AB, and considering it as the second last symbol, we will wait for the next symbol, and it can be either A or B. In both the condition, we are going to accept this string because we have encountered small a as a second last symbol. So either we will have small a or small b from state AB, we are going to accept it. So that's why here ABC is a final state and AC is also a final state. Now when we are in the state ABC, either we have input small a or b. So suppose we are having next input as small a. So this will also be accepted because considering it as considering it as the last symbol, this a is a second last symbol. So in that case also this string will going to be accepted. Now from state ABC, if we are having input small b, so considering it as last symbol, this a is second last symbol. So in that case also we are going to accept this string. Now from state AC, if we are having input small a, then considering it as the second last symbol, we will wait on state AB for the next input. If it will small a or small b, in both the cases we are going to accept it. Now from state AC, if we are having input small b, then we will move to state A and we will wait for the next input small a, so that we can move to state AB and we'll wait for the last symbol, and it can be either A or B. And in both the cases, the string is going to be accepted by either state ABC or state AC. So this DFA is satisfying the given condition, and this is the equivalent DFA. So this is all from my side for today's session. Thank you for joining.